Recording in progress. Okay, then let's continue. Kubernetes. Actually, Kubernetes is a vast topic. Okay, there are a lot of things that we need to learn. The command lines, how these that, for example, the applications deployment, how the node creation, content creation, checking the fade, then inspecting containers. There are a lot of scenarios that are coming to Kubernetes. Okay, so yesterday we configured EKS. That means Elastic Kubernetes Service, fully managed by AWS. So this is one approach. Okay, when we need that Kubernetes service. So it's a easy process. We can quickly configure Kubernetes. So the next way to approach Kubernetes is self-hosted. Here it's fully managed. So coming to self-hosted, we need to configure all the parts. I mean, the master part and worker part. Then coming to network, so many things are there. So all aspects we need to configure. Okay, so we need to manage all areas. Then one more way to deploy a very simple minimal version of Kubernetes, that is called a Minikube. So for a testing purpose, okay, I mean, before deploying to real Kubernetes, we can test our application using Minikube version. Okay, so that we will learn today. Minikube. So Minikube is a minimal version of Kubernetes. We will get the actual Kubernetes. That means after configuring the Minikube, we will get the command line interface that interact with the Kubernetes. Okay, so we can use kubectl command, we can deploy application, and we can run application, test application, everything we can run. Okay, using Minikube. So it's similar like Kubernetes actually. Simply we can deploy and test applications. Only for test. Okay, this Minikube we didn't provisioning in production environment because we need a single machine for creating Minikube. A single machine we can run Kubernetes. For example, it's EC2. So we need to install the dependencies, application, everything inside the machine. After that, we will get the Kubernetes. So coming to self-hosted, how we configure? We need to configure first. We need to select one machine and we need to make that machine. This is a EC2. Okay, this is our master node. Then we need to configure another machine, EC2. Okay, so this will be our. I mean, this second machine we need to configure and we need to add that machine to that master. So coming to master, the master have one worker node here. Got it. If we need more worker node, then we need to configure another machine, EC2, and adding to the master. So coming to the Minikube version, we need a single machine. Okay, just a single machine we can provisioning Minikube. Got it. Any doubt? So then coming to Kubernetes, okay, Kubernetes. Some some key terms are there. Okay, we need to learn some service types, services. What are the services under Kubernetes? Okay, services. Commonly, there are three services comes under Kubernetes. Okay, the first one is cluster IP. What is service? Coming to Kubernetes, a service is responsible for accessing internal pods. Okay, for example, in Kubernetes there are a lot of containers and pods are there. Okay, so we need to access that pod. For example, this is a Kubernetes cluster. Okay, this is a Kubernetes cluster. Consider this is a worker part. Okay, where the worker part. So here this is first node, that is EC2, node 1, node 2, the second EC2 machine, node 3. Consider there is 4 node. Okay, that Kubernetes cluster have 4 node. So coming to each node, there are number of ports are there, right? Port 1, port 2, again here port 1, port 2, like that. So for example, yeah, for example, coming to these ports. Okay, so internally this is actually internal. Okay, this is inside cluster. This is inside cluster. So inside cluster, these are the nodes and pods. Okay, so these applications, sometimes these applications needs to talk with each other. For example, this pod communicate with the second pod. Sorry, the first pod belongs to node 2. Or the similar network connection we need to set up inside the Kubernetes. Okay, so that the cluster IP is a internal internal network connection. Okay, like we can call like that. Okay, internal connection. So if we set up a service, okay, service means service.yaml. For example, we have a service.yaml and the service type is cluster IP. That means all the resources within the Kubernetes clusters have only internal network connectivity, no external connectivity there. Got it. So as per the requirement, we need to choose the service type as cluster IP. So only internal communication there coming to cluster IP. The service type is equal to cluster IP. So in another scenario, some applications are in pod 1. Okay, in the node 1, there is a pod 1 there running. And this application is a front-end application. So we need to expose the application to public. So we need to create another service for that specific pod. And we need to change the this is a default actually. Okay, cluster IP is default, so we need to change accordingly for our with our needs. Okay, so this specific application or the service we need to expose, so that we need to change to not port. Not port is another service. Okay, or load balancer. So three services are there commonly. First one is cluster IP default one. Second one is node port, and third one is load balancer. So when we use node port or load balancer, so node port and load balancer will expose our application outside the cluster. Okay, so anyone can using node port and using node port or load balancer. So for a test purpose, okay, for testing or small size applications like like uh, it's a simple application or similar application, not complex application. Okay, so that we can use Notepad. Mostly we are using Notepad for testing cases. Okay, like so when we using load balancer, that means for coming to production. Okay, some complex application or need to load balancing application. This load balancer service we use for exposing our application. So there is a service YAML there. So the service type is equal to load balancer. So this will be mostly using in production environment. So whenever changing our service type is equal to load balancer, if the Kubernetes cluster is managed, then the AWS will create a load balancer for this specific access or specific route. Got it? Anyone have any doubt? I'm audible, right?
Yes, sir.
Anyone have any doubt? So basically, these are the types of services within Kubernetes. The cluster IP is default one that will exposes the service internally within the cluster. So coming to node port, it's expose a service on a static port on each node IP. Okay. And coming to load balancer, it's expose the service externally using a cloud provider load balancer. That is AWS load balancer in EK's scenario. My Visual Studio is all of you can see, right? Visible?
Yes. Yes.
Okay, Mahesh.
Yes.
So this is then coming to Kubernetes. There are two types of approach that we can use for deploying or creating application or container or code. Okay, the first one is declarative and second one is imperative. So most probably we are going with the declarative because we using the YAML manifest to deploying application. Okay, so here you can see is a way of how the declarative YAML looks like. Okay, so this is actually a declarative way. So here you can see the API. The first thing is API. That is, we need to specify or specifies the version of API that we are going to use. So here you can see it's a V1. Then the next thing is kind. So here we provide a kind as service. Kind is equal to service. So what will happen? It will create a service within our Kubernetes cluster. So the kind that will define the type of Kubernetes objects. Okay, there are a lot of objects within Kubernetes. One is service, then pod, deployment. These are the common objects in Kubernetes. Then the metadata. So the metadata contains the names and labels of the service. Okay, here you can see the name, that is my service. Then coming to the label, that is app, my app. Then the spec under the spec, actually spec defines the services behavior. Okay, like which ports to target via the selector and the port mapping, everything that we mentioned under the spec. Then the service type, that is cluster IP. So before I told you, like there are three types of services that we use in Kubernetes: cluster IP, not port, and load balancer. So here, in this example, the service type is cluster IP. So whenever we providing the type, just to see like cluster IP. Cluster first C is capital, then IP is capital. If load balancer, then it's look like load L capital, B capital, load balancer. Okay, looks like this. For node port, P capital and N capital. Got it. So this is the way of like deploying applications or YAML file using declarative way. So what is imperative way? So I'll show you an example of imperative command. Okay. So we didn't create any YAML file for if you go with the imperative. Just type the enter command in a line like this. So this will create our application. So this is a kubectl command, and we need to talk with the kubectl. Please expose the pod. The name of the pod is my app. Then the type cluster IP. This is for the services actually, and the port that we need to expose, the container port, that is 80, and the target port 8080. Target port means the host machine port. Okay, the container port and the target port, both are ports. I mean, coming to containers perspective and the machine perspective. So this way, this is actually a imperative way of deploying application. We need to type the enter command and hit enter. It will uh, download the package and everything. This is actually for the service. Okay, service. We exposing service using imperative way. We can go with this command. If we go with for deploying application or downloading engineers, then we can directly run that from Docker Hub. Okay, using imperative way like kubectl run. Then the image name we need to mention. Like I will show you one command too. So this is a command. This is a command for exposing application, and this is a command for deploying on application. So kubectl, then run. Run what? This is the name that we given for our application. In name we can given. Then the image dash that image is equal to, we need to mention the image. Okay. So here we mention the image name. So what will happen when running this kubectl command? This will searching for the public image that names corresponding to kubecode, the React to-do list app. So this is actually a public repository. Okay, this is the username and this is the application name in Docker Hub. So it will download and it will create a pod with the container in our Kubernetes. So two approaches are there. Then coming to real world scenario, we are mostly work with the YAML file. That is the declarative way. Okay. So anyone have any doubt? All good, right?
Yes, sir.
So yesterday we deployed Kubernetes EKS. So today I will show you how to configure a Minikube version of Kubernetes. Okay, that is called Minikube. So my screen is visible, right? AWS. Yes. So just to go to deploy one server. So I'm launching one EC2 machine. Type it Minikube. I'm going with the Ubuntu. I'm choosing Ubuntu 22. Okay, that version. So machine is up and ready. Okay. So I'm just updating the package manager. So yes, it's a package updated. So we are going to install Docker. Okay, first we need to install Docker. Sudo install docker.io. apt. After installing Docker, we need to install the kubectl command line tool within this machine so that we can manage the Minikube version or that Kubernetes. Okay. So similar way we can download and install that. Like, so that part is done. This is actually see the curl command. We use the curl command. So what will happen? It will download the packages from this directory, and we change the permission as well for the command like kubectl. Then see we make it executable. Then we moving sudo move. Actually, we integrate we included multiple commands within a single line. So it's a time consuming process. So it will. I mean, if you go with the single commands, then it will take time. So we can include all the things using the ampersand, C double ampersand. Then we can add another command. So that command will execute. So the next thing is we need to download the packages for the Minikube. Paste. So that's fine. So this is same downloading command code. So that will download the Minikube uh, latest release files from this the URL. Okay, this is the URL we providing. Then we same way we adding another command like to change mod executable that Minikube. We change the modification. Okay, so after putting this command, it's executable. Okay, so the Minikube can execute whatever they need. Then move. This is a move command. So it's moving the Minikube to this directory, user bin, user local bin. Then the next thing is we need to install one more thing that is called a network tracker, okay, within the machine. So there is a service called uh, contract. It's related to the network tracking. So I'm just installing. That's fine. Then I am going to create a Docker user and adding that to a group, okay, Docker group. And all done. So the last command is any doubt about the last command? That is uh, the actually it's used to add the current user. Okay, there is a current user to the Docker group. So it allowing us to run Docker command without need of sudo. That's why I adding the sudo user mode if dash ag Docker user and user group Docker. So the user mode means that command used to modify a user properties in Linux. So that user mode and that ag dash ag the dash a flag stand for append. Okay, append something. So here we use dash a and dash g specify the group to which that we want to add the user. So uh, the Docker that's a group that we need to add. The group that Docker is a group here and user representing the current login user. The current login user here is C. This is a user, Ubuntu. Who am I? So current user is Ubuntu. So here what will happen? We will provide the current user to adding to the Docker group. So after that we didn't. Why we adding this? After this we didn't add any sudo command. Okay, so we can directly search the Docker commands without sudo. That's all. Then we can directly starting the Minikube server. So there's a command for starting Minikube. Minikube start driver is equal to Docker. Exiting insufficient to CPU available. Oh, I am using a single core CPU. That's why it's said like see Minikube need at least two virtual CPU. Okay, Docker has less than two virtual CPU available, but given sticker at least two to available. So what will we know we need we do is we need to scale this server. Okay, we can go with the vertical scaling. So how do a vertical scaling? Anyone? Because in this scenario, our resources doesn't meet the Minikube installation. That only one core CPU for this machine. See details. See number of virtual CPU. That is one. So we need at least two virtual CPU to move with the cube Minikube. So we need to add more resources, right? So there are two types of scaling. There one is horizontal scaling and one is vertical scaling. For horizontal scaling, we need to add one more machine, okay, similar machine, and we need to like it's a it's a clone of this machine, okay, like identical machines. If we go with the vertical or horizontal scaling, for this scenario, we need to go with the vertical scaling because we need to add more resources within the same machine. So after that, after vertical scaling, the number of CPU will be like might be two or whatever we need. Okay. So for that, we need to stop the machine first. Stop machine. That's one of the like prawns of uh, vertical scaling. Because if the machines belongs to any uh, production, then it will impact the application or the service that's running. So in this case, we can go with it because this is a test purpose or like that or learning purpose. So just yeah, now it's stopped. See, it's stopping. It will take some time to getting stopped. So here you can see this machine is currently stopping mode. Okay, not fully stopped. So after stop, we go select the machine and go to actions and go to instance settings. Okay. So here we can see instance, change the instance type. So we need to go there. This is now it's not enabled. This is disabled. So after stop, yeah, now it's stopped. Now we can check again. Go to instance settings. See, now it's enabled. So just open the change instance type. So currently the instance type is T2 micro. So we need to change to T2 medium. That's fine. What type T2? Yeah, T2 medium is there. Okay. So if we select T2 medium, I think we will get two virtual CPU. That's enough for, yes, see, this is a comparison. Okay. In previously we used T2 micro, so only one CPU. So coming to T2 medium, we will get two core CPU and RAM as well. It's like 2 GB RAM here as well. Not 2 GB, 4 GB RAM. Sorry. For T2 micro, only 1 GB RAM. T2 medium, 4 GB RAM. And all others are same. We can go with this change. So I change the machine type. See, now it's T2 medium. It's listed here. So we need to start the machine again. Start it. So this way we vertically scaling machines. So running, connect again.
Sir, the same way we can scale it down as well.
Right.
Okay.
So now I'm starting the Minikube. Okay. Yes, now it's working. It will take some time. Okay. See, now it's creating, generating certificate and key, booting up control plane. So done. See, kubectl is now configured to use Minikube cluster. And the namespace is default namespace. Okay. So we can check the kubectl command line is working or not. Kubectl get node. See, you can see the node Minikube, then status ready control plane. Its role is control plane. Everything we can see here. Then kubectl get pod. So there is no pod. We didn't create any application or anything in here. Then kubectl get service SVC. The default one, Kubernetes service there. Then kubectl get namespace, short form NS. So these are the namespace after the Kubernetes. The default one is default namespace. Under the default namespace, there is nothing because if we didn't create any namespace and we didn't mention any namespace for our application deployment, all the application deployment under the default namespace. And these are the namespace for the master part, okay? That kube node is kube public and kube system. These are the default namespace whenever creating Kubernetes. So these are the namespace and the related components are under the master part. So that's fine. Then we can quickly like deploying one application via imperative. Okay. Previously I show you one kubectl command line that kubectl run. See, this is the imperative way of downloading or pulling the image and running that application in our Kubernetes system. So that is kubectl run. And then we mention one name, okay, to-do list app. Any name we can given here that as per the application name or any name. And then the image. Here we need to mention the image, dash dash image is equal to, we need to mention the proper image. That's all. Just hit enter. See, it's created. Or to-do list app created. So again, I'm checking with the kubectl get pod. See, pod one created and one of one. That means inside the pod there is one container is running. This is a way how quickly we can pulling the image and running our application. Got it. So similar way, now the application is running in our Kubernetes. So how we need to deploy or how we expose the application? Similar command like kubectl expose. The expose what the pod. Okay. Here the pod is to-do list app. Then the type, we need to provide the type. Coming to Minikube, we need to expose using we can service called node pod. Okay. So this is mostly for testing purpose. So we can use node pod. So this is a command to expose the similar above service. That is kubectl expose pod. Then the pod name. The pod name is to-do list app. See, this is a pod name. Got it. So the same name we provided here. To-do list app. Then the dash dash type is equal to. So which service type we are going to expose this application? That is node pod. Or we can mention whatever the service like cluster IP or node pod anything. Then yes, the port. This is the port we need to mention the container port, okay, which port that the application exposing. So it's port number 80 we mentioned. Then the name, to-do list tab, we need to mention the name for the service. So here we mention the name, that is to-do list service. Got it. Any name we can provide here for the service. After hit enter, what will happen? The Kubernetes will create a service connection named with the to-do lists service and expose the above application. See, service created, the name to-do list tab service, and it's exposed. We can check the service kubectl get svc. See, now it's one more created, service created. And you can see that node port and everything we can see here. Anyone have any doubt? Good, right?
Yes, sir.
There is a command for checking our application is ready or not. kubectl service. Yes. So this for this, who will join now? Presentation. So this is the way we accessing an application internally. Okay. So here what will happen? We expose. I mean, within the container. Okay. Within the, sorry, this is not container. This is the server. So within our Minikube, we create, actually this is a we first we configure a EC2 machine, then inside the EC2 machine we created a small environment called Minikube. So inside the Minikube we set up the Kubernetes everything. Okay, so the application currently running inside the Minikube. Okay, not connected with our EC2 machine. I will explain with the diagram. So now here we have a EC2 machine. Okay, so this is our EC2. So inside EC2, we created a service called Minikube. Minikube. So after that, we will deploy application. Okay, like one port running port. So and this we created a service as well for the port. Okay, this is a application port application. Then this is a service for this application, and we use node port as service type node port. So now the requirement is now this application is exposed, okay, but within the Minikube it's exposed. But for example, the remote users, okay, the remote users needs to access the application. So how they access this EC2 machine? Public IP, right? Public IP with the port number, specific port number. So in this case, as of now, the application is it belongs to the Minikube for but we need to do something called port forward. After port forwarding, for example, if we now accessing this application using the EC2 machine's public IP, we can't see the application because this is fully isolated. The application and the service isolated within the Kubernetes environment, sorry, the Minikube environment. There is no connection between this specific service and our EC2 machine port number, any port number. Okay. So we need to forward the port number with the service port number with the host machine port. After that, there is a connection between the EC2 machine and that specific service, that is Minikube. For that, we need to create a kubectl port forward. So I will show you how to do that. So now after that, we use or we access our application from outside. Okay, that is means outside the EC2. So we need to enable the corresponding port for incoming traffic that is related to the EC2 machine security group, and we can use the port. Copy, paste. So this is the port forward command. Okay, kubectl port forward. Port forward what? The service we created. Okay, so the service we created name is to-do list apps.service. So here we need to mention the service and the service name. Okay, the same thing that we created, this thing. So that we need to mention here, and the port number. So this is the port that we are going to map with our EC2 machine. So we need to enable the port number 3000 in our EC2 machine, and the container port is 80 that we already exposed above when deploying the application. And dash dash address, that means who can access the application, that is 0 by 6 0 0 0 0. Anyone can access via the port number 3000. This is mapped with the container port 80. Okay, so here we port forwarding, hit enter. See, it's forwarded to 3000. So next we need to enable the port number security group, edit inbound, and one more 3000. Anyone can access. Save rule. Go here, copy the public AP and paste. Then mention the port number 3000. I think I have some permission issue. I will paste. Can anyone check? I pasted in the chat. Anyone following?
Yes, sir, I'm checking.
Okay. There, I think it's a to-do list app or something like that.
Yeah, I'm able to access that.
Okay, fine. So this way we exposing application after installing Minikube. So in which scenario we use Minikube? For the development phase. Okay, we didn't promote or use this type of Kubernetes in deployment. Sorry, development. Got it. Anyone have any doubt?
Sir, are we gonna get the instructions for whatever we have done so far? Like the way you gave for the Docker?
I didn't get you actually. What do you need? Documentation, right?
Documentation plus the task, you mentioned all the steps.
That I will share. That I will share.
Okay.
I will share the task along with the video. Otherwise, if you
Yeah.
face any issues, then you can just review the videos. That's why I'm waiting for the videos.
Okay. And we haven't received the video for Docker as well, so just letting you know.
Sure, sure, sure.
Okay, sir.
So going forward, we can set up one more way, like the self-hosted Kubernetes too. Okay. Like now, yesterday we configured manage a Kubernetes, and this is Minikube is for the development phase Kubernetes version. Okay. And one more Kubernetes version that we need to configure, that is self-hosted Kubernetes, fully managed by us. Got it? All of you?
Yeah. Okay.
Yeah. Then we can wind up today's section, right?
Yes.
Okay,
Sure,
then.
sir.
Yeah. Bye bye.
Okay, bye. Bye.
Fine. Thank you.